Quadratic functions come in several different forms. Two of the forms we're going to look at is vertex form versus standard form. Vertex form is when you can see the vertex in the equation that you're looking at. Standard form is when it is multiplied all the way out and you arrange it in order from highest to lowest degree. So you've got your x squared first, then your linear term, and then your constant. So any quadratic function can be written in either form. So for example, 2 times x minus 3 squared plus 1 is the exact same thing as 2x squared minus 12x plus 19. So if we take a look at these, they look very different. This is one where I can see the vertex. Our vertex would be at positive 3, 1. I can see that this was moved to the right 3, it was moved up 1, it was stretched by 2. So this is where I can see all of my transformations that happen to the graph. And you can't quite see it like this. This is x squared minus 12x plus 19. You cannot see the vertex. You cannot see how it's moved left or right. It has to be in vertex form in order to see that. So changing an equation from vertex form to standard form, all you have to do is just do the math. What that means is you've got 2 times x minus 3 squared plus 1. Well, the first thing I'm going to do is the squaring. So I'm going to ignore the fact that 2 is there, I'm going to ignore the plus 1, and I'm just going to square x minus 3 times x minus 3. Once I'm done with that, once I'm done squaring the binomial, then I'm going to distribute the 2 into that new trinomial. So I'm going to multiply 2 times x squared, I'm going to multiply 2 times negative 6x, and I'm going to multiply 2 by positive 9. Still, the positive 1 at the end, the plus 1 is just hanging on for right now. We're not doing anything with it. After we distribute the 2, I'm going to combine like terms, so the 18 plus 1 is just 19, and when you're done, you have it in standard form. 2x squared minus 12x plus 19. So let's look at a couple more examples. Alright, so you start with it in vertex form. I'm going to multiply out the binomial, so x minus 1 times x minus 1. When I'm done there, I look to see if there's anything I was supposed to multiply it by, and there's not. So now I'm just going to combine my like terms. The minus x is minus 2x, and the 1 plus 8 is just 9. So this is the exact same equation as that one. This one has negative x plus 4 squared plus 3. So again, I'm going to multiply out my x plus 4 times x plus 4. What I get there is x squared plus 4x plus 16. The plus 3's are still there, and I've got this negative out front. So this minus sign out front is like having a negative 1. I need to distribute throughout the parentheses, but not to the 3 because he's not in the parentheses. So I get my negative x squared minus 4x minus 16 plus 3. And then once I combine my like terms, I'm just left with negative x squared minus 8x minus 13. One more time, I've got to take my x plus 1 and square it, multiplying it out in 2 places. I've got my 2 out front, so I've got to distribute that in. Once I distribute everything in, I combine my like terms of 2x plus 2x and get 4x. Plus 2 minus 2, well, there's not going to be a constant term, and that's okay that I just end up with this. So my function in standard form is 2x squared plus 4x. Now, yes, they can go from vertex to standard form. It can also go from standard form to vertex form. So there's a couple different methods. The first one we're going to do is called completing the square, and it's really going to be the method that I'd prefer you to use, but I'm going to show you a different method just in case. So I have my x squared plus 6x plus 8. The first thing I'm going to do is identify my b, which is 6. Then I'm going to take that number and divide it in half and then square it. So 6 divided by 2 squared is the same thing as 3 squared, which is just 9. So I'm going to take my new number 9 and I'm going to add it inside the parentheses and I'm going to subtract it outside the parentheses. So I get x squared plus 6x plus 9, and over here I get 8 minus 9. So I've got to add it in one place, but I need to remember to subtract it in the other. Well, this right here is the exact same thing as x minus 3 squared. If we go and take a look over here, I'd started out with something like this, which was going to be x squared plus 2x plus 1, and that's the same thing as x plus 1 squared. So it's just taking it backwards. So in order to know what I put in here, and that should be a plus, in order to know what I put in there, I just take that 6 right here, and I divide it in half, and it goes in the middle. So I get x plus 3 squared and then minus 1 on the end because 8 minus 9. So all I did was rewrite this trinomial as x plus 3 squared. Okay, so now I know that my vertex is at -3, -1, and my axis of symmetry is at -3. Alright, so my vertex was at -3, -1, and my axis of symmetry is at -3. So over here in the steps I said to identify the b, figure out what b divided by 2 squared is, group the first two terms together with parentheses, so I just stuck parentheses around them. I'm going to add in that number I got when I did the b divided by 2 squared inside the parentheses and subtract it from the end. And then the part in the parentheses is my x plus b divided by 2, that whole sum squared. And I use that to write vertex form. So let's see again. So I've got my x squared minus 4x plus 3. So I group that off into parentheses. Half of 4 is 2. That number squared is 4. I'm going to add it on the inside and subtract it on the end. I know that this is the same thing as x and then just half of this number, so x minus 2 squared. And then over here, 3 minus 4 is -1, so it's x minus 2 squared minus 1. The only reason we're even bothering with squaring the thing here is to know what to subtract off there. I could look right here and know that I'm going to end up with x minus 2 because it's x and then half of this number. So my vertex is at 2, -1, and my axis of symmetry is just at x equals 2. So here's another one. 3x squared plus 24x plus 50. There's a little note right here. When there's a number in front, you have to divide it out. So what we're doing is like reverse distribution. Instead of distributing into the parentheses, I'm going to pull one number out of the parentheses. So if I were to look at this and distribute it, I would have gotten 3x plus 24. So see how I would have ended up there? I'm just pulling it out front. So I'm going to pull that 3 out front before I do anything else. Now I'm going to take half of this number and square it. So half of 8 is 4, 4 squared is 16. So 16 goes right in here. But before I go subtracting it off over there, I have to take that number, multiply it times this one, and then subtract it over here. So 16 times 3 is 48, so 50 minus 48. And I know that this is just x plus half of that number 4, that quantity squared, and then plus 2, because 50 minus 48 is just 2. I can easily see my vertex is at -4, 2, and my axis of symmetry is going to be at x equals -4. Alright, so one more. So I've got I might have a couple more actually. -x squared minus 2x plus 3. I group them together. I've got that -1 out front. I have to pull it out. So I'm going to pull it out of here and here. And I get my -1 out front using reverse distribution. I'm undistributing that -1. Then I'd say half of 2 is 1 squared is plus 1. Plus 1 times -1 is -1. So 3 minus -1. And I end up with the negative x plus 1 squared plus 4. So my vertex is at -1, 4, and my axis of symmetry is at x equals -1. So in case that's too much, there's an alternate method. So if you were good with that, you don't need to know this alternate method. If you're sitting here thinking, that's insane, I'm never going to be able to do that, then let's try this alternate method. I call it fill in the blanks. Alright? In my vertex form, my standard vertex form is your function equals a times x minus h squared plus k. Okay, so I'm just filling in the blanks. So my a is going to go here, my h there, and my k there. Where h is just the x value of my vertex, and k is the y value of my vertex. A is actually given to you in the standard form. So you already have 1 as soon as you get the problem. So you have to find a, h, and k, and then plug them into the formula. So a is right here at a equals -2. So I'm going to use the formula for axis of symmetry. So this is a new formula. X equals the opposite of b over 2a. If I'm given a standard form and all they're wanting is axis of symmetry, I can plug in my opposite of b right there, plug in my a right there, and get my answer. So I get the opposite of b. So the opposite of -16 is +16. And then -2, there's my a, and there's my 2. So 16 divided by -4 is the same thing as -4. So already I know my a equals -2 and my h My x value is -4. So I have 2 of the 3 already. So now I just need to plug in the h back to the original problem to figure out k. So -2 times -4 squared minus 16 times -4 minus 32. This is where you can use your calculator. Now I've worked it all the way out, but if you plug this into your calculator exactly like this, k will equal 0. So now you have your a, h, and k. So you fill in the blanks. A goes right here, h goes right there, and k goes right there. Simplify where you can, and I get -2 times x plus 4 squared, and there's no need to write anything at the end. So just a couple more like that real quick. I identify A, B, and C. So to figure out my axis of symmetry, I take the opposite of B over 2A, and I get -5. So my h is going to be -5. Then I plug in -5 to the equation to get my k. So -5 squared plus 10 times -5 plus 20, and I get my k equals -5. Then I fill in the blanks, a, h, and k. And f of x equals x plus 5 squared minus 5. So here's one problem. I'm going to do it both ways. So the first way is completing the square. I have 3x squared minus 6x plus 5. I'm going to separate off that first group with parentheses. I'm going to pull out the 3 using reverse distribution. Then I'm going to take that 2 and I'm going to divide it by 2 and square it. So 2 divided by 2 is 1 squared is plus 1. 1 times 3 is going to have a minus 3 down here. So I end up with 3, and then I look right there, x minus 1 squared plus 2, because 5 minus 3 is 2. So 3 times x minus 1 squared plus 2. Same problem, just going to do it a different way. I've identified my a, b, and c. I've plugged in my b and my a, so the opposite of b, so -6 over 2 times 3 equals +1. I get a equals 3. I've already got my h equals 1. Just need to figure out k. Plug in h to all the places where x was. So 3 times 1 squared minus 6 times 1 squared plus 5. Plug it into your calculator, or work it out a little piece at a time, and I get the number 2. So k is going to be my 2. So there's my a, h, and k, or 3 times x minus 1 squared plus 2. It's the exact same thing.